a few things that we need to get clear first. You may go ahead and pause the video so that you can copy down what's on the screen. But when we are simplifying, we are only canceling the factors and not individual terms. So let's talk about the difference between factors and terms. Terms are always separated by addition or subtraction symbols. So the example that I've given to you is 3x plus 4, which is an expression that is created by two separate terms, x and 4. Factors, however, are always separated by multiplication. So in the example given, we have 3 times 2x minus 5. In this example, 3 and 2 minus 5 are both factors. The 2x minus 5, that factor is actually created by joining two separate terms. We made it into a factor by including parentheses around it. When you put parentheses around two or more terms in an expression, then you can create or make terms into factors when you are creating your own expression. Now, the reason why sometimes students get confused between the two is because both terms and factors can be made of the same things. They can be made of constants, variables, or expressions. So be sure to always look for how are these separated from the rest of the problem. If it's separated by addition or subtraction, you're looking at a term. If it's separated by multiplication, then you're looking at a factor. Let's write down the steps in factoring a rational expression. Again, you want to pause the video to get these down. But the steps include, number one, we have to factor anything that can be factored. So if you're still struggling with the ability to factor a quadratic, make sure that you come and get a little extra help so that you can be successful in the standard, because all of our standards for Chapter 8 will require you to factor first. Step 2, you're going to circle each of the factors, and it may seem like an extra step, but there's a difference in when I changed and started making that part of my process in the number of students that were confusing terms and factors and canceling the wrong thing. Once we started circling our factors, the amount of mistakes made went down drastically. So at least until you get really comfortable with these problems, be sure to circle each and every factor. Step 3, we have to identify undefined values. We do this by setting all of our factors in the denominator equal to 0 and solving. So when we have a rational expression, we have a fraction, and that fraction is going to most likely have a variable in the denominator. When we have a denominator, we have to be very aware of what would make that denominator equal to 0. Because remember, when we have 0 in a denominator, we have an undefined expression. So in order to find out what value for x would make it equal to 0, we take all of our factors and we set each of them equal to 0 to see what would make them equal to 0. Because factors are multiplied and anything times 0 equals 0. This is an important step that you don't want to skip or save to the end, because oftentimes when we do that, we can forget about factors that were canceled out in the meantime. Those still need to be included as undefined values, because your undefined values always refer to the original problem. Then once we found our undefined values, we can cancel out identical factors that appear on top and bottom. Now here's a helpful hint. If two of your factors are very, very close to canceling, but their signs are off, try factoring out a -1. Sometimes that will help to make your factors be identical and you can cancel them out. The reason why I really want to make a stand on the difference between terms and factors is when we have problems that look like number 2. I have a lot of students that look on top and look on bottom and be like, oh, x squared on top, x squared on the bottom, I can cancel those. But remember, these are terms because they are subtraction after them. They're not factors and they can't cancel. So I just wanted to point out that's one reason why I make such a big deal about terms and factors. Let's go ahead and take a look at some examples here. I'm going to zoom in a little bit to make it a little bit easier for you to read. All right. So our first step, remember, is to always attempt to factor anything that can be factored. Now in example number 1, x plus 7 on top cannot be factored any further than what it already is. So that's going to remain the same. The bottom, though, I can factor out this quadratic by using a times c. Factors of that, 1 and 28, 2 and 14. 3 doesn't work, but 4 and 7 work, and those are the last two factors. I need my signs to be one positive and one negative, and we're going to have the larger factor be positive so that we can add to equal positive 3. Don't forget about tossing this into the box, because remember, if there was a number in front of this x, those that skip the box get a wrong answer. So make sure that you're doing this every time. And negative 4x and 7x round out our boxes. What can I take out of the top row? I can take an x out. The bottom row, I can take 7. The left side, I can take x. And the right side, I can take negative 4. So our factors in the bottom, we're going to have x minus 4 and x plus 7. We're going to go ahead and circle all of our factors. Here's x plus 7. And in the bottom, we'll have x minus 4 and x plus 7. Time to find all of our undefined values. To do that, you're going to need to set each of your factors equal to 0. And we need to figure out what will make this factor equal to 0. So we'll add 4 to both sides. So x equals 4. Subtract 7 to both sides. And we get x equals negative 7. So if x were to equal either of those two numbers, we would get 0 in our denominator. So these are our excluded values. To show that they are excluded from potential numbers plugged in for x, we put a line through them and say that x cannot equal either of those numbers without creating something undefined. Our final step is to go ahead and cancel identical factors. That would be x plus 7 and x plus 7. Since there's nothing remaining on the top, 1 would be in that place, and the bottom would be x minus 4. So our simplified answer is 1 over x minus 4, and our excluded values are x can't equal 4 and x can't equal negative 7. Number 2, we need to factor everything that we can. That means that we're doing a times c for the top number, or the top expression. Negative 24 is a times c, 1 and 24, 2 and 12, 3 and 8, and 4 and 6. It's going to multiply to be a negative number, so 1 positive, 1 negative. Add to be a negative number, so we want the larger factor to be negative. That means that we're going to use 3 and negative 8 in our box. We'll go ahead and set up our box here. X squared, negative 24, 3x, and negative 8x. What can come out of the top is x. Out of the bottom, we have negative 8. The left side, x. The right side will have 3. So the top part of our answer, or of our problem, will be x plus 3 and x minus 8. Go ahead and write that. On the bottom of our fraction, we have x squared minus 64. Those are both perfect squares, and there's a minus in the middle. That means that we're going to have difference of squares happening. Remember, difference of squares requires you to have 2 sets of parentheses. We're going to take the square root of the first term, which is x, and put it in the first spot of each one. Then the square root of the last term, which is 8, and put it in the second spot of each one. Then we'll have 1 plus and 1 minus. Everything's been factored. It's time to circle our factors. Look for identical, before we look for identical factors, we need to figure out what's going to make the denominator equal to 0. Take each of those factors found in the denominator, so x plus 8 and x minus 8, and set them equal to 0. I'll need to subtract 8 from both sides. And I get that if x was negative 8, I would have an undefined expression, so we're going to exclude that value. Adding 8 to both sides means that if x was positive 8, then I would get 0 in the denominator. So we're going to go ahead and exclude that value. Once we've found our excluded values, we can cancel out identical factors. As you can see, we have x minus 8 on top and bottom, so those are going to cancel out. What remains is the numerator of x plus 3 and the denominator of x plus 8. So my simplified answer is x plus 3 over x plus 8, and my excluded values are 8 and negative 8. Number 3. Now, number 3 includes 2 different variables. When we have 2 different variables, we actually cannot identify our undefined values. So instead, we're going to skip step 3. The only time that we skip that step is when I have 2 different variables. So include that step on anything that has a single variable. We still need to factor. So the top part is already factored for us. We'll copy it over as C plus D. The bottom part, I can already see that I can factor a 3 out of both. And I'm left with 2 perfect squares with a minus in the middle, indicating that I'm going to have the difference of squares again when I factor. C plus D will be on top, and our bottom will be 3 and 2 sets of parentheses. We'll need to go ahead and extend our fraction bar out. Square root of the first term will go into our first box. Square root of the last term will go into the last box. And we'll have 1 plus and 1 minus. Circle each of our factors. C plus D on top, 3 and C plus D, and then C minus D. We're going to skip our step 3 because we have 2 different variables, bringing us straight to canceling out any identical factors. C plus D on top, and on the bottom. There's nothing remaining on the top, so we'll put 1 instead. On the bottom, we'll have 3 and C minus D. Take a look at number 4. I need to factor everything that I can. So that includes doing A times C on my numerator. So A times C would give me negative 40. Factors of negative 40 include 1 and 40, 2 and 20, 4 and 10, and then 5 and 8. Multiplying to be a negative means I'll need 1 plus 1 minus. Adding to be a positive will indicate that my smaller factor will be the negative factor. We'll include negative 5 and 8. So I'll draw my box down here. We'll put y squared in the first spot, negative 40 in the last spot, and then negative 5y and 8y will be my final 2 boxes. What can come out of the numerator is y. Out of the denominator, I can take an 8. The left side, I can take y, and the right side, I can take negative 5. So my new numerator will be y plus 8 and y minus 5. My denominator looks like it's already set up to be difference of squares. So I'll need 2 sets of parentheses because I have 2 perfect squares with a minus in the middle. Now don't be fooled, our previous sets of perfect squares, our difference of 2 squares, had the variable happening first. In this case, we don't have the variable happening first. So we're going to take the square root of 25 and we'll put it in the front of both of them. Then the square root of y squared goes into the second spot for both of them. 1 plus and 1 minus. We'll circle our factors. And find our excluded values. So 5 plus y will equal 0, and then 5 minus y equals 0. If I subtracted 5 from both sides, an excluded value would be negative 5. And what would make this equal to 0? Subtract 5 and divide by negative 1 if you need to, but positive 5. If I did 5 minus 5, that would equal 0. So my excluded values are 5 and negative 5. And we're looking for identical factors. Unfortunately, I don't have one right off the bat, but I am awfully close. This one has a y and a 5, and so do these. So we're going to go ahead and rewrite this so that the y is first. So our numerator would look like y plus 8 and y minus 5. We're leaving that to be the same. Our denominator, though, the 5 plus y would become y plus 5. And the 5 minus y would become negative y plus 5. Not quite exact yet. The issue now is the signs are wrong. So remember, when we're close to canceling, we're going to try factoring out a negative 1. So if I divided this factor, each of them by negative 1, I'd get negative y. So I don't want to do that one. That one's going to remain the same. So y plus 8, y minus 5, move it over just a little bit. And then the bottom, we decided that y plus 5 is going to stay the same because factoring out a -1 is not going to help our cause. But if I factored a -1 out here, I divide this by -1, giving me positive y, and this by -1, giving me -5. That's what I have on the top. So factoring out a -1, and I just put all GCFs in the front, would give me -1 in front and that y minus 5 that I was looking for. So when I go to circle all of my factors now, we should have identical factors that can cancel. And I do. I have y minus 5 on top and y minus 5 on the bottom. Those will cancel out for me and leave me my answer of just y plus 8. I'll write it up here. Y plus 8 on top. Then on the bottom, we'll have -1 times y plus 5. And don't forget about your excluded values over here. Last problem. Again, we're going to need to factor everything that we can. And looking at number 5, the first thing that I notice is I can take a GCF out on top, which leaves me with an x in front and a squared minus b squared. Well, lucky for me, those are two perfect squares with a minus in the middle. So I can factor that again. Two sets of parentheses. And I'll have square root of the first term, which is a, going in the first spot of each one. Square root of the last term, which is b, going into the last spot of each one. One of them will be plus, and one of them will be minus. For the denominator, I do have a common factor here. I have a y that can come out, leaving me with b minus a. Now, both of the ones on top, just like we saw in number 4, have a first and then b. These on the bottom have b, then a. So if you want to go ahead and take the time now to go ahead and rearrange them, you absolutely can. So y is equal, or y times -a plus b. Now they're at least in the right order. You're not going to need any excluded or undefined values here because I have two different variables. So we're going to go ahead and circle our factors. X, a plus b, a minus b, y, and -a plus b. We've got some that are pretty close. I mean, that's a plus b, but I've got -a. And that's a minus b, and that's a -a. So let's try factoring out a -1 here and see if we can get some identical factors. Factoring out a -1 in the denominator would leave the numerator to be the same. And in the denominator, that -1 would go all the way in front, then the y, and -1 divided into this factor would be a positive a and a -b. Now, when I go to circle my factors, I can see that I actually have an identical factor that we'll be able to cancel. On top, I'll have a minus b, and on the bottom, I'll have an a minus b, canceling those off to give our final solution left over. X times a plus b over -1 y.